Welcome everybody to 6-2, which is using proportions. So here we talk a little bit about proportions, we talk a little bit about cross products. We'll start with the definition, which is what is the definition of a proportion? And a proportion is an equation. So the first thing that you need to know is you're going to see an equal sign. And on each side of the equal sign, you're going to see a ratio. So a proportion is an equation stating that two ratios are equal. So, something with variables would look something like A over B equals C over D. But let's not get freaked out by this because you guys have been looking at proportions for as long as you've been looking at equivalent fractions, right? Because we know that 2 over 3 equals 4 over 6. So this is an equation stating that two ratios are equal. So that would be a proportion. Now, when it comes to something special about proportions, okay, we can state this in English or in math. In English, we're going to say that the cross products, right, we'll talk about what that is, of a proportion, okay, are equal, okay? And the best way to show what that means is by telling you what it is in math, right? So in math, that would be, if we have a proportion, so if A over B equals C over D, right? We want to use variables because it works in all cases, right? Then, okay, cross products, meaning we go like this, and we take the denominator of one and the numerator of the other, and the denominator of one and the numerator of the other, and those things are equal, okay? Those products are equal. So if A over B equals C over D, then A times D equals B times C. And we better go ahead and say, so long as various stuff isn't zero and it's just the stuff in the denominator, so B and D cannot be zero. So if you want to know what that looks like with our example from before with the equivalent fractions, well, we had 2/3 equals 4/6. Take the cross products, right? That would be 2 times 6 equals 3 times 4, or 12 equals 12. And that's a good way of checking to make sure that your ratio, or excuse me, that your proportion, that you've written it correctly, if the cross products are in fact equal. So there's lots of different types of problems we can do with proportions. One type of problem, which is fairly straightforward, would be, do these pairs of ratios form a proportion, right? So 1/3 and 16 over 48. So you would want to do 1/3 equals, maybe we'll put a question mark because we don't know, 16 over 48. Then we're going to take the cross products. So that would be 3 times 16 equals 1 times 48. Is that true? Well, 3 times 16 is 48. So yes, and so this is a proportion. We could remove that equal sign. What about another one? 12 over 40, is that a proportion proportional to 2/5? Well, let's see. Do the same thing, 12 over 40 equals, we'll put a little question mark, 2 over 5. Again, we're going to take the cross products. 40 times 2, does that equal 12 times 5? Well, 40 times 2 is 80, 12 times 5 is 60. So that's a no. So this would not form a proportion. Okay, another kind of problem would be to, if you were given a proportion, right, and you had to solve for a variable. So in the case on the left here, we have A over 25 equals 52 over 100. Some of you can probably see, like, oh, we're kind of comparing 25 to 100. 25 is 1/4 of 100, so A is probably 1/4 of 52. But if you don't see that, we're just going to go ahead and take the cross products, right? So if it helps, you can draw this, although I don't think it's necessary, right? And we would end up here with a times 100. It doesn't matter which one goes on the right and which one goes on the left, equals 52 times 25. That would be 100a, write that a little bit more conventionally, equals 1300. And now we're down to just the socks. We've got a one-step equation, right? Divided by 100, divided by 100, a equals 13. Kind of plug that back in and check. Okay, 13/25 equals 52 over 100. So yes, definitely on that one. The one on the right is a little bit more complicated because you can see that there's two terms with that variable. So when you take your cross products here, let's just be careful because when you're multiplying that 2, it's no longer just times the a, right? It's times the a plus 3. So it's times the quantity a plus 3, and of course that means parentheses. So I like to have my variables on the left, so I'm going to say, well, that's 2 times the quantity a plus 3 equals 6 times 7. I do a little distributing here. 2a plus 6 equals 42. Now I'm at shoes and socks, but it's not complicated. 2a equals 36. And divided by 2, a equals 18. You can even kind of come back up and see, like, okay, if a is 18, then this would be 18 over 6 is 7 over 2. And it's like, this would be 21 over 6 equals 7 over 2. And then, you can kind of see what's happening, right? Divided by 3, divided by 3. So that works. Let's look at one more kind of problem. So I just want you to sort of be exposed to this problem, and this is it's really a dimensional analysis problem, right? So we know how to do these, and some of you are going to be able to do this in your head. The question says, what if we have somebody that's 4 feet high? How tall is that in centimeters if 1 foot equals 3.5 centimeters? Now again, I'm guessing that some of you are just doing some multiplication and coming up with an answer. But I do want you to see that we could write this as a proportion and then take the cross products. So it would look something like this. Well, if 1 foot, if 1 foot is 3.5 centimeters, then what about something that is 4 feet, right? We're going to call that how many centimeters? Well, if we don't know something, we use a variable, okay? So in this case, we're then going to take the cross products, right? We're then going to do top left times bottom right, make our little x, and I'm going to pay attention to the units. So I'm going to get x times 1 foot equals 4 feet times 3.5 centimeters, and I'm going to notice that my feet are going to cancel. And all that's left to do is see that we have on the left x, and over here 4 times 3.5 I believe is 14, and I have some units there. But I can set up that proportion and take the cross products. Could I have set it up in a different way? Actually, yes. I could have set it up as 1 foot over 4 feet equals 3.5 centimeters over x, and you'll notice we're going to get the same cross products if we do it that way as well. So we will do more of those in class, but that just gives you a little bit of an insight into some problems with proportions.